All right, so let's we're live. Let's do this. So we are continuing with Rust generics. Yeah, and also I couldn't stream at the regular time yesterday, so I'm streaming it at this time now. I'm gonna get to it. We are going through the Rust language reference, and I think yesterday we stopped at test case. This is for generics now. Stop a test case for empty bounds, right? So what we saw is that you can use empty bounds, like basically you can have uh wait, hold on. You can have something like traits that have empty implementation, we don't have any implementation, right? And you can use them. So we saw that equal and copy are examples of such traits that don't have any implementation. So a consequence of how bounds work is that even if a trait doesn't include any functionality, yeah, you can still use it as a trait bound. But but why do they call it empty bound? Yeah. Okay, I guess that's so they call it empty bound, but it's really about the fact that you are using maybe a trait, yeah, a trait that doesn't have any implementation. You just call it like empty bound. Okay, so the idea there is that it doesn't matter, right? It's still gonna work as you expect, right? So I think we had an example of that yesterday. We didn't write this by hand, but we get the concept, right? Mm, so, but I actually um I want to write this by hand so that we sort of get used to it. Like we um sometimes I like to go through, I like to write the code so that we see how it's going to behave in practice, so we basically we have some structs, right? So unit structs, and we have some traits, and then we have implementation for some of those traits on certain structs, like here. And then we have two functions that two generic functions over a generic parameter that we define here as t. And just a second, let me also send this um a second. Yeah, let me send a notification. One second. Um done. Okay, so wait, just a minute. Let's see. Okay, so that's done, taken care of. So yeah, I was saying that it said, and then so basically we have unit structs, and um we have empty traits, so basically traits that don't have any implementation. And then we have some implementation. So we have some implementation of the traits for certain of those structs. And now we have some functions, some generic functions that take a generic parameter and then just return something. Yeah. In this case, they return a reference to okay, so yeah, they take a generic parameter that is a reference to that type, yeah, and then they return a reference to a string size that has a static lifetime, right? So yeah, and then what we are checking is that when we create bindings for those unit types, those structs, those unit structs, yes, we're trying to now use the function, right, by providing references to those unit structs here, right, and then confirming that confirming that the trade bounds work, even though they have no implementation. Yeah. So let's try to come up with that. Yeah. Let's try to write that ourselves. So what do we have? Let's say I want to write something that we can relate to. Um, let's say we have a um, let's say we have a struct called where we have let's say we have a pizza struct. Yeah, it's just a unit struct, and let's say we have a burger struct. Yeah, also unit struct. Then let's say we have a trait called um, we have a launch trait. Yeah, a trait called launch. It's it's also a it's an empty trait. Basically, there's no implementation on it. Or rather, it has no implementation. Um, yeah, and this doesn't have to be generic anyway. Yeah, and then we have let's say we have another trait called uh breakfast. Yeah, like so. Um, mhm. And let's say we have a struct. I don't know. Let's just say cake, right? So let's say we have cake, and then we have like breakfast, and then let's say we have a trait called dessert. Yeah, just just I don't want to write the same thing, so that we just want to see how this works. Yeah, or in practice, like writing the code ourselves, so we also establish the concept here. Now, when we have these, we can have an implementation. So we can have an implementation um, for pizza, for example. We can say like we implement launch, for example, right, for pizza. Yeah, and that's it. We can also say we implement, um, let's say we implement another, let's say we implement dessert for cake. Yeah, so we have these. Yeah, and then we have a generic function. Yeah, that we can call. Uh, what do you call it now? Um, mm, we can call it eat. Yeah, we can call it. We can say the function is eat. Maybe it's a generic function. So for us to define a generic function, we would so basically you can eat any you can eat something, right? So basically anything, and so we need to define that generic parameter, type parameter here. We can define it as t, right? It can be c, can be anything, but by convention it's t. So now we define generic parameter. We can then have a we can have the function have its input parameter now. So basically, it can have like it can take something, right? So let's say it takes it takes t as input, and then it's a reference to that type that's a type that we have here. Um, yeah. So basically, we don't want to take ownership, but we just want to take reference to it. Yeah, and then it should return for us. I mean, according to the example that they had, it was just I mean, we don't have to follow that anyway, but we can just return. Mm, so we can say eat, and it can return for us. Let's say a or let's say should I say eat now? Yeah, eat of course. And then we can return a reference to a string slice, right? So reference to let's say string slice that has a static lifetime, and this can be like um I know eaten. Yeah. So yeah. So this can be the function here, and let's say we can also have a function called snack. So basically, I want to snack on something, and it's also a generic function that takes. By the way, we don't use this, right? So we can ignore this, right? We don't have to have a parameter here or any parameter here. And now for this one, we can also take a reference to this type here, parameter that we create, and then we can also um, do this, and this can be snapped. Yeah. So now what we want to try out, right, to see is that yeah, what we again we are, what we're trying to do here is empty. We want to test out empty uh they're called empty bounds, yeah, empty bounds, yeah, they're called, yeah. So where you specify trade bounds for traits that don't have any implementation and see that they still behave the same way as traits with implementation, right? So I don't like to have the trade bound specified here. I prefer to have it on this side. So we can say where, in this case, where t is, well, you want to eat where t is a or implements lunch, for example. You can eat lunch. Yeah, I'm just gonna say lunch is a trait, yes, right? So lunch or lunch, or let's just say lunch actually. I don't want to say breakfast. Let's just leave it as lunch. Yeah, let's implement lunch. Yeah, and now for this one, for we can snack where t implements dessert. Yeah, so I'm just gonna put it like so. Yeah, and now in our function, we can say we can create um, like breakfast be, or maybe let I can say let pizza actually. I can say let pizza be pizza. Yeah, like so, and then um, yeah, we can have pizza, and we can say print. We can print and say um, let's say pizza. I think we don't need to do this, right? Because yeah, okay, we do because eat is going to give us. So we can now say eat and then pizza. So now we have the mismatch type here. Oh, sorry, it's a reference that we need, right? So that's fine. Yeah, this works. So we can eat pizza here, even though the trait here is empty, there's really nothing here. But when we say so, we can do this for pizza because pizza implements lunch, right? So we have an pizza implements the lunch trait, and according to the eat function, it works. Each function only takes a type where it implements launch, right? So that works. However, if we created let dessert now be dessert. Oh wait, oh sorry, dessert is a trait, so we cannot create it like that. We can say burger, for example. Yeah, or maybe I should say cake. Yep. If we say cake, let cake be cake, right? So let cake be cake. And then we try to do the same thing and say let e uh cake, right? And then do eat and take a reference to cake, we would have a problem. Yeah, because it says the trade bound cake lunch, which is the trade here, right? Is not satisfied. So if we want to see this properly, we can look at it here. It says the trade bound cake lunch is not satisfied. The trade lunch is implemented for pizza. Yeah, of course. Blah, blah. So I think we see the issue here. So the trade is not satisfied. It requires lunch, right? It requires something that is a lunch to be passed there, but we pass cake, which actually implements dessert. So yeah, we see that. So we see the same issue, right? So this is basically what we have here, right? So this is the same implementation as is here, or rather, with different. So we wrote this in our own way, right? So we understand the concept and we just wrote it the way we yeah. So but meanwhile, if you have a cake, if you have cake, and instead of saying eat, let's say let's snack on cake, yeah, and then here we then say snack, we call snack, which takes dessert, right? And then we say a reference to cake now here. Yeah, now it works. Yeah, so this is fine for us. Okay, so that's cool. Now we can go on to the next thing, which is multiple bounds. I think I discussed this yesterday as well, but yeah, let's see. So multiple bounds for a single type can be applied with a plus. I think we I think we also looked at this yesterday, if I'm not wrong. Yeah, I think we're just reviewing it. So multiple bounds for a single type can be applied with a plus, of course. And then like normal, different types are separated with comma. So basically what you have is where you want multiple bounds for a single type. So let's say for cake now. So if let's say eat function should be both launch and let's say and launch and dessert. This is how it would be. Yeah, sorry. This is how it would be. So it's now required by a bound in eat. So we already see this failing here because pizza doesn't implement lunch and dessert. If we wanted to make that possible, we would have to have an implementation um dessert for pizza. Yeah, and then that would solve our problem. Yeah, as you see. Now, so that's how we would do so for example, in compare prints, we do like debug plus display, right? We specify these straight bounds here, so it works here. Now, what about when you have multiple different types? So in this case, we have T and U. So let's say we wanted to combine stuff. So let's say we have mm, let's say we have a function called combine, right? That takes two parameters, T and U. So you want to eat multiple things at once, right? Or you want to, I don't know, order multiple things at once, whatever. So now we define and then these are two generic types of meals or whatever you want to call them, right? And then you so we define the type parameters T and U. Now we want to specify the input. We want to use them as an input parameters. We can say um let's say we don't really care. A reference to T and also like a reference to U, right? And then it should tell us, should also give us, um, in this case, I guess we can, yeah, we don't use any, mm, I don't know, let's see if we can do, uh, Wait. What is the challenge here? Okay. Yeah, okay. Now here, you should tell us, I don't know, combined, yeah. So that's it. So now, what if you wanted to specify trade bounds for, you wanted to restrict the type that, you want to restrict the type that can be passed to combine, So we can do that simply as we did the other one, right? We can say, we can also do that with our where clause here and say where T implements launch, for example. So we cannot combine, you have to combine maybe a launch menu or something that is a launch, right? Um, with like U that is dessert, something like that. Yeah. And then this will be fine. And if you wanted to combine this, you can say lunch plus breakfast, for example, right? Yeah. So yeah, we see it. This is how you would do it. Yep. Okay. So we have that one now. We can move to we're just gonna look at where clauses, and now we already use our where clauses. Oh, I think okay. So maybe I should have actually moved to the next one. Okay, so because I guess we already understand, we already know this whole thing. So a bound can also be expressed using the where clause immediately before the opening. I mean, it's exactly what we did, right? So, like I said, we could have specified this here and say like lunch plus breakfast, yeah. But as you see, it's not very readable. We can then and then here we say dessert, right? So it's hard to see which of these are the well, what is the declaration here of the type, and what is the trade bound? It's hard to see that. So it's better to do it like so. But anyway, we understand how to do the. Oh, I think I yeah. Okay. Now, some cases where clauses can be useful when specifying generic types. Yes, yes, yes. Okay. And trade bound separately is clearer. So that's what I just said now, right? Where you want to make it clear, you do this. But there's even another case where it can be clear, which I also like, right? I think we saw this yesterday as well. So this is where you have where the implementation wait, hold on. Yeah, okay, that's what we saw previously. But the second case is when using a where clause is more expressive than using normal syntax. The implementation in this example cannot be directly expressed without a where clause. Um, yeah, yeah. I think this was the. I think yeah. I think this is something I want to also write out. Let's see it. So I think so. This was like a trait called print in option. Yeah, and then it's like it has a function, print in option itself. And now for this, we want to express this with a trade bound using like debug. I think what they had here was like they had a generic function and they now applied a trade bound to it and say that so this is just a trait that was created. Yeah. And then for you to use this now, you have to restrict it and say, okay, that it should only accept types or generic types where option of that type implements debug. That's it. Hmm. Where option of that type implements debug. Okay, I mean I didn't. Okay, yeah, of course. So where option of that type implements debug. So we want option of that type implement debug as our bound because that is what's being printed. Doing otherwise would be wrong bound. So basically, you're saying now you can print. um some self. Why? Okay, why are you able to? Why are you doing some self here? Okay, it's not the type itself that implements debug, but option of the type. How does that even work? Interesting. The printing option. So then let's write this. I want to see. So you have a trait called printing option. This is how we write traits again. No, sorry. It's like printing option. Yeah, sorry. The syntax was. You have a trait called printing option, and it has a function called print. I guess we can call it print. Doesn't matter, right? Or maybe we can call it print in option. Yeah. And what it takes self. Just a declaration. Now we can apply a trade bound here. I'm trying to make sense of the example of like to understand exactly what they mean there, right? And like how that works. So this trade can be used by, I mean, literally any piece of code here, right? But now we want to restrict, we want to print in option. Okay. So we can restrict we can apply trade bound to restrict what is passed, the type that is passed to to um or how this is going to be used. How would that work? So we do an implementation of uh so we implement, this will be a generic implementation now, right? So generic implementation, and then we're implementing, now we create a type, a generic type, and then we say we implement printing option now. Actually, I think this trait should be like so, yeah, printing option. So now we implement printing option for that generic type now. Yeah, yeah, I think this is, yes, we need to now also have the function, yes. So we can say, so we need to have the function here. We can say for function printing option. Yeah. Now the function is here. We've written this out for, this is the generic implementation now. All right. So this is how you work for any any type or any code that uses this trait now. However, we want to, for us to be able to print this, we want that it should implement debug trait. Right. So we can do that with trait bound and say like where this implements debug. Yeah. Okay. So now coming to our implementation, now we can say, actually, yeah, that was my question. I think from the example the code that they had there in the example, it was not T that implements debug. It was not the type that implements debug, but it's option of the type that implements debug. Like, so why not like this, right? And I think what they did was like print line value or something, and then they did like, and then they said, I think it was some self, but why not like so? Yeah, so why not like so? Why not like so? So why can't, excuse me. Why can't we have um so we have a trait. We have this trait. So I think they use a vector, right? So maybe I can say let V be uh, a vector of like values like so, and then I can say, I mean, print an option is generic here actually, but does okay. I think we're about to realize why it's option of the type and other type. So vector, does vector implement debug? I don't. We can check it, but let's see. We will know already, right? So we can now say, um, let's see. Um, how do we use this actually? Um, okay, yeah. So we can say what now? How do we get to this self? Hmm. How do we get to use this? Can we do v dot? Yeah, we can do v dot printing option because it's actually a generic uh a generic uh type. This is actually very cool. Okay, so let's see. I mean, I just want to see this will work, right? So vector implements debug. Is that it? Can we see vector, the vector type, or like? Oh wait, this is core. Yeah, vec struct actually. Yeah, and what does it implement? Does the struct implement debug? I think that would be under great implementations. It does implement debug. Yep. So that's why it works. So so yeah, if we try to run this, we would get, yeah, we would get that. Yeah. However, that's not the exact same example that they had there. So this is why this works, right? Right? Because this is already printing an option anyway. So we want to print in option. So we can then say that option of that type implements debug. If we change that and say where option of that type implements debug, okay. Consider restricting the parameters with this. Okay, so now we say where option of the type implements debug, and then we take the type here and then we say mm, okay. Okay. So we just say where option of the type implements debug, and then and then with that we can. traits implementations, but option also implements debug. Of course, that's why it works. But I mean, for me, I can't really see I can't really see the use. Like, okay, so wait, we just wanted to. Okay, okay. I guess what you want is to say like, just want to print whatever that thing is as an option, and that's it. Yeah, I guess that's what you want to do here. So it's like saying, um, what if I did let V be none? Um, okay. Now type annotation is needed. Yeah, of course, like I mean this is an option actually. The option of okay, option of something, yeah. Wait, okay. I wanted this to be okay. Let's say an option of I32 and I say none. Yeah. Okay. Now it is some none. Yeah, okay. I was just I'm just checking, I'm just looking at the example, right, to see, trying to understand this concept. But I think we get it. We get it. We get what they mean here, where they say like you can restrict this based on this is another use case. I think we get that part. What is next? There's a new idiom. I think this is the one that I we should have continued with today. But yeah, let's it was also good that we went through the code to revise what we had done before, to go over it again. We continue from here tomorrow. Yeah, we also wrote some piece of code. Yeah. Yeah. All right then. See you. Bye.